So here we are in a similar scene as the one that you have already seen earlier. And when I now select the camera, that is here on layer 2, then in the properties I can change some of these settings. For example, we also have here the focal length. And when I change the focal length, then it looks different. So we can zoom in and zoom out. Now when you zoom out, then you basically create a wide angle lens. So now the angle is wider, and I could press G, Z, Z to walk in, and you can see the typical effect of a fisheye lens or a very wide angle lens. But if you zoom in by increasing the focal length, then you would have to walk much further away to be able to see the whole scene. So the focal length obviously has a big impact on how the scene looks like, and of course also if you had feature points here and would track them, how they would move in relation to each other. So that is very important information for the solution. Now the second very important setting here is the sensor size of your camera, and you can set that down here. So when I now change this value to something lower, then it seems as if I would be zooming in. And if I increase the size of the sensor, then it looks like as if I would zoom out. So when I set this to something very large and press G, Z, Z, then apparently I can create the same effect as if I would change the focal length. So focal length and sensor size are somehow very similar, even though they of course are totally different things. Okay, by the way, you can also have some camera presets here. For example, just as before, I could set it to the Canon 550D, and it seems as if I would have zoomed in. But why does that happen anyway? Maybe we should have a look at a real camera, or maybe not a real camera, but at least a 3D camera. And I'm not talking about this object here. That is just a representation of that Blender camera here. That is not a real object. So let me just hide that layer and instead enable these ones where you can see a real camera. So that is a DSLR camera, or at least a 3D representation of that, with the lens and the body. And of course on the display, since this is a DSLR camera, you also see the image that has been taken with that camera. Now the question is, how do we generate that image? Well, we have rays of light coming from here, entering the lens of the camera and hitting the sensor and generating that image. Now these rays of light do not just enter the lens and somehow get there, they enter the lens in a certain way. So you have these rays of light from these corners going into the lens, and in this lens they converge at a certain point. Maybe I should disable the lens shortly. So because of the lenses, it bends the light in a certain way so that the rays of light converge at a certain point. And from this point, the rays of light go on, hit the sensor and create an image that is kind of flipped. So if I disable the camera, then you can see the image. So that is the image that is on the sensor. But since the sensor is usually just flipped top to bottom, on the camera back or on your final output, you get the correct image, just because the sensor is flipped top to bottom. Now the question is, what is the focal length? And basically the focal length is the distance between the sensor, or also named film back in usual film cameras. So this plate, the sensor that generates the image, the distance between this area and the convergence point. Sometimes you can also hear that the focal length is the distance between the sensor and the lens. And if I enable the lens again and disable the camera, that could also be, if I increase that. So this is the last lens, the primary lens, so to say. And here we have the convergence point inside that lens. So that would then be the focal length. Now the question is, what happens when you zoom? Now when you are zooming, then you change that focal length. So now the convergence point is somewhere here inside of this lens here. So by zooming, you change the distance between the focal point and the sensor, and that is now a larger focal length. So you have sometimes lenses with, I don't know, 200 or 300 millimeters, and that would be a tele lens or a zoom lens. And these zoom lenses generate these images where you just see a small crop of that what's in front of the lens. So if I disable this again and go to my real camera, then you can see that when I zoom in, so I increase the focal length, I seem to be moving forward, but what really happens is I just make my field of view smaller. You can also see that here, how this length now increases. And since you're zooming in, you see a much smaller portion of the image here. And that is exactly what happens when you zoom in here, also with that camera. So the rays of light are covering a much smaller portion of this image here than with a wide angle lens. So when you zoom out with a wide angle lens, you can see a lot of things. So if I go here and zoom out, so make the focal length really short, then you can see how this angle is now much bigger than before. And when I look through that, I can see much more. So that is the same that we can see here. So, I mean, of course, it doesn't really make sense anymore, but you can see that the rays of light now cover a much bigger area than before. So this is zooming in and zooming out, so changing the focal length. Now, what's happening when you change the sensor size? Maybe let's have a look at that. So we've got here the sensor inside of the camera, and the sensor generates the image, like so. So these are the rays of light that hit the sensor and thereby create the image. Now, what happens if you change the size of the sensor? Well, we can easily do that. So before in our example, I had set my sensor size to the size of the Canon 550D. And that size is, if you remember, is 22.3 millimeters and 14.9 millimeters height. Now, if you change the size to something smaller, then what's happening is you get the same effect as if you would change the focal length. And if I make the sensor bigger, then it seems as if I would be zooming out, just because the rays of light are different. Now, keep in mind that the focal length didn't change at all. So this lens here is still, let's say, a 35 millimeter lens. It's just that now, because the sensor is much bigger, the angle, the field of view is different. And that is why changing the sensor size has almost the same effect as if you would change the focal length. So set this back to the default, which is, I believe, 35, and Blender is 32. So if I now split the viewport so that you can still see the camera here, but now in this viewport, look through the camera by hitting 0. So let me zoom out. All right. So I change the focal length and you see what happens. Zoom in, zoom out, like so. But the same effect happens if you change the sensor size. So if I make this smaller, we even get here in the viewport a longer camera. So it has the same effect as if you would change the focal length. And that is the reason why people talk about the crop factor. Maybe you have heard about that. So crop factor means that usually, for example, you have the Canon 5D. Let's go to that preset here. So Canon 5D. So that has this sensor size, 36:24. But since we know the relation between focal length and sensor size, you can now understand what's happening if you set this to a different camera. So for example, the Canon 550D or just any other APS-C DSLR. Then focal length didn't change, same lens as before, but this is now much closer. That is just because of this relation between sensor size and focal length. So if someone is saying this camera has a crop factor of 1.6, then it means that the sensor of the camera is not a so-called full frame sensor like the Canon 5D, but that the sensor is smaller, for example like the one on the 550D or the 7T. And because the sensor is smaller, the same lens will create different images than on a full frame camera. So, for example, if on a full frame sensor camera you can use a 28mm focal length for a nice indoor shot with a reasonably wide angle, then on a camera with a smaller sensor you would have to use a focal length that is 1.6 times shorter. So when I can use the 28mm on a Canon 5D for a nice indoor shot, then on the 550D I would have to use an 18mm focal length for the same image, because 28mm lens would be too close. So the same lens with the same focal length can lead to different images depending on the size of your sensor. So in the end what really matters is just the field of view, which is depending on the relation between focal length and sensor size. So with that in mind, I think it is now clear why the focal length and sensor size is so important. So make sure that when you are filming or when you supervise the filming of the shot, that you note down the sensor size, the camera model, and especially the lens model and focal length. So if it was a prime lens or a fixed lens, then of course there is only one possible focal length. But if it has been a zoom lens like this one, then you have to really make sure to note down at which focal length you have been shooting. If you don't know the focal length, then in most cases you can at least guess what it might have been, just by experience. So for example, if I go to my 3D viewport here and look at this cube with this camera, then currently this is set at 18, and if it would be set at 10, you can see at the grid how this changes perspective. And also if you zoom in, then this now also has a very unique look, and just by experience you can sometimes just guess what the focal length might have been. But especially if you really just guess the focal length, then it can always be wrong. And there is a way to make Blender try to guess the focal length, and that is here in the Solve panel, the Refine menu. So they're currently set to nothing, so nothing will be refined, but you can change that and set it, for example, to focal length. And when you solve now, Blender will try to guess the focal length. Now, that doesn't always work. In this case, you can see it has worked, so it has been set to 21. So obviously, at least with these markers, 18mm focal length was probably wrong. And you can also see that the solve error now is even lower than before, so the solution seems to be better now. Now there is one thing about this refinement, and that is that it not always kicks in, at least currently. So in some cases, especially when you have very smooth movement, for example on a dolly shot, then it can be that the refinement just will not be triggered. And in these situations, it can sometimes help to set the focal length to something really wrong, like 50 or so, if you think it was a wide angle lens, and use the focal length refinement. And because of this very wrong value, Blender can or might then try to calculate that. But usually it will just work. The next thing here that I want to look at is the lens distortion. That is also something that is always very critical to get a good solution. So especially here in this shot, where I have been using a rather cheap zoom lens set to a rather wide angle, there is some distortion here. Maybe we can hide the curves for now. So either toggle them with this button, or you can also use the shortcut Z, the Z key. So now when you have a look at these lines of the concrete roof, you can see that maybe they are not quite straight. So it seems as if they would be bending down. And also maybe I can show you that something here on the outside. Maybe you can see that this is a little bit curved, so it is not perfectly straight. So there is some lens distortion because the way the lens has been built, the light gets bent as it goes through the lens, and the image will then be also not quite straight, but there will be some distortion, especially here at the borders of the frame. And there is a way to describe that distortion, and that is by using these K values here. Now, I have to admit, I'm not entirely sure what exactly these values are standing for, but the most important of these is the K1 value. Sometimes you can also use K2, but at least from my experience, K3 is rarely used. Okay, so we can use these markers and slide them around, but we don't see any effect. And of course, it would be stupid to just try any values and hope for the best. Somehow you have to find a way to control that. Now, there is a way to automatically calculate that by using the Refine menu. But first we can also try to match that by hand. And to do that, you can go to the distortion mode, and here you can enable the grid. And the grid gives you an idea of the lens distortion. So if I now change this K1 value again, you can see how the grid bends. So if I move this in the negative direction, you can see that it bends kind of inwards like that. But if there is a positive value, which is also sometimes happening, then you get this kind of distortion. And there is another way to visualize that, and that is by using the grease pencil. Now let me disable the grid again and instead go here to grease pencil and then draw a straight line. And you can draw straight lines by holding down the D key and the Control key and then left mouse button drag. So Control and D and then just paint here, and now I can draw a straight line. And if I place it here, and maybe you can see that this is now slightly bent. But if I move the K1 value into the negative direction, it starts to fit a little bit better to this line in my footage. And also if I draw a straight line here at the border, like so, then it also bends so that it kind of better fits to my footage. Of course, it would help if you would shoot a distortion grid before you start filming your scene. So if you just have an image, a sheet of paper with straight lines and film that, then you can use that, bring that into the movie clip editor, and with that grid you can then use these straight lines of the grease pencil and thereby try to find out the lens distortion. But because these lines now fit a little bit better to the footage, we can try to solve that again. And for that, we go back to the tracking mode and click on camera motion, or just use the shortcut, which is Shift S. So Shift S to solve that. And obviously now we have a much better solution. So even though we were just guessing and eyeballing the whole thing, it really did help. Now you can see that in the distortion mode, you can see the distorted grease pencil, but as soon as you go back to tracking, you have the original straight lines of the grease pencil again. But because we don't need them anymore anyway, we can just delete this grease pencil layer. And now maybe we can try to make Blender find out the lens distortion values. So go to the refinement menu and switch from focal length to focal length and K1. Then Shift S again. Now it's refining the whole solution. And obviously we have been so close with our eyeballed K1 value that it didn't change at all. So maybe to try to trigger that, we can set this back to 0. Maybe also set this back to 18 like we had before, just to see if Blender starts finding out these values by itself. And hit Shift S again. So it refined. Now we are at 0.44, which is really great. And you can see now the focal length is actually 19 almost. And we have a K1 value that is slightly different than before, but still surprisingly close to our initial guess. Okay, maybe let's see if we can improve that even more by using K1 and K2. And now we are at 0.31, which is even better. But that doesn't mean that you should always use and calculate K1 and K2, because especially if you have not as many markers, and currently I don't have that much, then calculating the K2 might be even more dangerous than not calculating that, because the K2 value influences more the edges and borders of the frame, whereas the K1 value is more the overall distortion. And because you not always have that many markers at the borders of the frame, it might be, well, more dangerous to calculate K2 in that case, because the distortion might be incorrect, even though the average solve error might get down. So in most cases, calculating K2 will bring down the average solve error, but it is not always a good idea to do that. But, well, I will do that most of the time. Okay, but anyway, that is now our final camera solution, and now it's time to create a 3D reconstruction from that.